Let me start this off by announcing that I do not have the best memory for birthdays. So imagine I had to guess 5 friends' birthdays. Weird bunch, aren't they? What would the probability be of me getting only one correct? In this scenario, we're assuming it's me who's the one guessing, who has an abysmal memory for birthdays and has absolutely no idea when these birthdays are. So I have the same probability of guessing each of these birthdays as a blind guess of 1 over 365. Truthfully, I can't really remember their names either, but please don't tell them that. Well, to answer this, we can use the infamous binomial distribution. This tells you the probability of success or failure at a certain given event, where in this scenario it will be whether I succeed or fail at guessing their birthdays correctly. However, binomial has some key assumptions such as there are a fixed number of trials, check, I'm only asking 5 friends. There are only 2 outcomes, check, right or wrong. They all have the same probability of success, check, since I'm assuming that I'm completely clueless. And finally, the probabilities are independent. Check. Guessing one person's birthday will not affect my chance of getting another birthday right. This means we don't have to use the dreaded normal or Poisson distributions. One extra assumption that I'm making is that none of their birthdays are celebrated on the 29th of February, as this would not make the probabilities the same, 1 over 366 instead of 65. So, now to write this mathematically, x is the number of birthdays I get right, n the number of trials, which is 5 guesses, and p is the individual probabilities of getting a birthday right. In that case, 1 over 365. This should be shown here, where n is 5 and p is 1 over 365. Now, I'd want to find the probability of getting exactly one birthday right, so I use PD distribution, which stands for point density, which is the one I'll be using because we only need to find the probability density of just one success, whereas CD, cumulative density, would calculate the probabilities of itself and before it. So, to do this, we use the binomial probability mass function, where R is the number of successful attempts. The complicated bit is n choose R, which is based off Pascal's triangle, which adds adjacent pairs of numbers to find the next row. The choose function can be written as n factorial over R factorial brackets n minus R factorial. That's a mouthful, where that exclamation mark stands for the factorial, which means every number below is multiplied by it. Eventually, these cancel down just to give you 5, and if you see through my workings, the rest of the probabilities, you end up with 1 over 365 multiplied by 364 over 365 to the power of 4. With some very easy mental maths or a calculator, you'll find out the probability that I guess one birthday right is 0.0135491, and multiply that by 100, 1.35%. However, the probability of getting them all right would be 1.54 times 10 to the minus 13, or 0.0000000000154%. Let's hope that's the amount of noughts. So, if like me you're not brilliant at remembering birthdays, it seems that very unfortunately the odds are not in your favour. However, even after such a likely humiliating defeat, you may still consider yourself very lucky. Evidence shows that your existence in the universe right now is magnitudes more improbable in the success of the universe than that of even guessing 5 friends correctly, as it seems we may be the only forms of intelligent life out there, which suggests that the probability you should be alive right now is 2 times 10 to the minus 24, which is over 100 million times more unlikely than that of guessing all your friends' birthdays. So it seems after all that the odds are in your favour, and you can appreciate that you're probably the luckiest being in the universe who gets to enjoy these friendships. Except now that I think of it, you may have to spend some time apologising to these upset friends. Thanks for listening.